Hello, everybody. I'm Andrew Teixeira, Assistant Professor of Chemical Engineering at WPI, and today I'm going to talk to you about some of our efforts in making our unit operations lab go virtual. So first off, before I get started, I need to acknowledge that this was an enormous team effort from the faculty to the IT staff and the students. Everybody really, and the technicians, I should say as well, everyone really made this happen, and I'll be presenting on behalf of the team. Before we get into it, it's good to think of what is unit operations. So this is the senior laboratory experience for our undergraduates in chemical engineering. It's a 3-story pilot scale facility located in Goddard Hall, and it allows students to really get that hands-on experience of rotating a valve, applying steam, seeing what happens on a gravity-fed 3-story column. It's really that experiential unit operations component of our curriculum. It's typically offered as a 4-hour lab session offered 3 times per week with about 25 students per session, working in small groups of 3 to 4 students on each experiment. That means we have between 4 and 6 experiments happening simultaneously within the facility, and there are 3 full-time faculty, 2 technicians, and 2 TAs to make all of this happen. In the hybrid operation, we found ourselves having to diminish our capacity in the lab itself, but we wanted to still maintain the high level of engagement. So what we did was we decided to run at 50% capacity. That means for every group, there are 2 students physically in the lab and 2 students working remotely with a bunch of technology to connect it all together. And the key outcome we wanted to keep in mind was we wanted those remote students to really feel engaged and involved in the experiment, monitoring the lab equipment, recording data, performing calculations, all of it. So here's a little snapshot of what some of the technology looks like if you're in the lab. So on the left, you'll see 2 students over here sitting in front of a computer. This computer has LabVIEW automation, which is controlling the piece of equipment in the background. The base level of integration is that computer is screencast to the remote users, just like you would do in a Zoom session. Here we're using Microsoft Teams, and you can see the students have their laptops where they have the 2-way chat, video, and audio as well. On the right, you see a couple of new pieces of technology. First, you'll see these pan-tilt zoom cameras, PTZ, which offer very high definition for looking around the lab, zooming into gauges, etc. It allows the remote users to control what they're looking at. The second thing you see is this student has a set of the Microsoft HoloLens 2 augmented reality glasses mounted under his hard hat. And that is not only casting everything he sees, but it's also superimposing content from the remote users onto his physical reality. And again, allowing for 2-way communication over audio as well. So here's a brief demo of what this might look like. Looking at one of the cameras in the lab, and this is a live view from inside our lab. So let's just let this load up. And this is the pan-tilt zoom camera where I can zoom around and zoom in and out of certain locations to perform readings. And we could also have these preset locations. For example, if I want to look at the gas flows, again, as a remote user, I can pan around to different parts of the apparatus and see what's happening inside this column in real time, and actually even be able to make recordings in real time that can help out the team. Okay, 2 more things I'd like to show you. The software interface. So this is Microsoft Remote Assist. So what you're looking at here is a screen recording from Microsoft Teams where the remote users are performing these calculations on data that was collected by the users in the lab. So in real time, this is being sent back and forth. There are multiple users logged in, and this is a Microsoft Teams recording. So anything from here can actually be sent to the person in lab. So this is a view from the student wearing the HoloLens 2 glasses, which actually superimposes the spreadsheet or whatever the remote users are sending onto their physical space, and they can grab and move that around. They can also mark up the space for the users. The next video here is Microsoft Guides. Whoops, over here. So Guides is another bit of software that allows students to have step-by-step information on how to perform the experiment in lab. So this gives them a guideline. It's somewhat difficult to see, but there's a little blue line. It shows up much more vibrant with the glasses, but it's showing them what to look at. The other thing they can do is they can take that whole card. There are also holograms all around the column. So this is a climbing film evaporator for a separation process. And this is being recorded in mono, one camera, but those holograms in the actual environment align perfectly with every part of the column. So this will let them go next, step through a complex procedure. One of the cool parts here is you can also embed videos that give additional information. So here, the user is being directed to turn on the cooling water for the condenser at the top of the column. So there are those holograms showing them what to do. But if they want more information, they can play this video of our technician operating the column. And the audio is muted here for convenience, but it does very clearly show them how to do each step in this operation. Okay, one other aspect we're doing with augmented reality, Rob Dembski and I have a grant through Rapid Process Intensification Manufacturing Institute, and this is for the pharmaceutical workforce development of the pharmaceutical industry as they're going from batch to flow. So we're using augmented reality as this archival expert training delivery method. And what I wanted to end with is looking beyond COVID. So yes, we scrambled very quickly to make this all happen during the world of remote learning and the necessity with the COVID pandemic. But we have thought about what this means beyond that. And what I have here is the list for what I think for unit operations. So what we've seen is that it increases the student engagement in large classes. So typically what this is required is we have a lot of faculty, a high faculty to student ratio with TAs and technicians. Well, here we're able to actually have this archival information stored in this augmented reality that can help aid the students even when they don't have all the faculty as much faculty interaction. The second point is that it could allow for the inclusion of non-traditional student populations, whether that's an international population, a remote population, mobility limited, etc. The third point is that it's an archival of educational training materials, so it can increase productivity, and we can add this expert training that would be difficult to administer to all the students at all times. The next bullet point is beyond unit operations and looking at other labs. So chemistry and mechanical engineering are considering similar implementations, applications for student-driven learning. It's a learn at your own pace, possibly even an asynchronous platform. And from a technology perspective, it does not have to use these augmented reality glasses. There are folks using cell phone apps to be able to do some of this. The last set of points are workforce development and continuing education. So I mentioned we have that RAPID grant for flow chemistry and continuous pharmaceuticals, but we've also reached out to our alumni advisory panels and such, and what they've told us, what they've told us is that they're actually seeing this in the industrial landscape. So they're using augmented reality already in some of these industries. So we're really preparing our students for it. So the final thought I'll leave with you is this one. This is a new way of learning where students teach themselves with hands-on experiences delivered by subject area experts. In my opinion, this is really just the beginning of that. So thank you for your time. I'll leave you with this photograph of myself and Professor David DiBiasio, where David actually was the one who taught me during my undergraduate times here at WPI unit operations. So I like to say we've come full circle, where he taught me with his technology, and now I'm teaching him some of the new tricks with mine. So thanks for your time.